Alright, number 2, we're going to be doing the same thing. We're going to try to find all the rational zeros. So we're going to take that last number, which is our constant, which is 3. We're going to divide it by the leading coefficient, and we're going to just list all the factors of 3, which are just 1 and 3. And then we're going to also list all the factors of the denominator, which is 1, and divide each number by that denominator. Each number in the numerator by the number or numbers in the denominator. So we get positive or negative 1, and then positive or negative 3. Okay, so now we want to actually list all those zeros. So as I was mentioning, this is a small list, so we could probably check those and get there pretty quick. So I'll go ahead and do that. However, if we get a big list, I will use a calculator. Alright, so 1. I'm going to try 1. X to the 4th minus, I actually want to just list the coefficients. So 1, negative 4, positive 2, positive 4, and negative 3. Not missing any terms. You got a 4th, 3rd power, 2nd power, x to the 1st power, and then none. Alright, so we're going to try 1. Write down 1. 1 times 1 is 1. Subtract, we get negative 3. 1 times negative 3. Negative 3. Subtract, we get negative 1. We get negative 1 here. We get a positive 3. And then 1 times 3 is 3, and we get 0. Okay, so 1 works. Now, it doesn't say anything about repeats, but sometimes numbers can repeat. We're not sure if it does. Let's try 1 again, see if it's a double root. So once you figure out 1 is a 0, we have a new polynomial. There's a couple things that we can do. So this is x cubed minus 3x squared minus x plus 3. So this is my resulting polynomial. Those are just my coefficients out front. We could try to factor by grouping. Factor by grouping is just grouping them 2 at a time. So let's say I take these first 2 terms and I take these second 2 terms, and I'm going to factor out what they have in common. These 2 have x squared in common, so I will pull out an x squared. And pulling out an x squared, what we have left, so this had 3 x's, we took out 2, so it has 1 left. This one had 2, we took out 2, so it's just minus 3 left. Now the way factor by grouping works is whatever your first parentheses is, whatever you have left, this needs to be the same. It looks pretty close. There's a 3 and x, but the signs are different. This is negative, that's positive, this is negative, and this is positive. So if we factor out a negative 1, and you always want to factor out something, even if it is 1, then you'll see that number. So divide by negative, it becomes positive. Divide by negative, that changes. Alright, so factor by grouping works. So we just did synthetic 1 time. We got 1 was one of our zeros. And now when you come up with the same thing in the parentheses, you look at those. What they have the same is x minus 3. So we're going to pull out x minus 3. So that's one factor. And then what is remaining is x squared minus 1. So x squared minus 1. Alright, now hopefully if you look at this, you notice this is a difference of squares. So this will factor. So we have x minus 3 as a factor, and then this will convert to x plus 1 times x minus 1. So when you set all of these terms equal to 0, you get x equals 3 as a factor, x equals negative 1, and you get x equals positive 1 again. So this one has what we call a multiplicity of 2, M-U-L-T, multiplicity, let's say times 2. So number 1 is a double root, and then we have 3 and negative 1. Okay, so does it say anything about identifying that? It doesn't. We're not going to list it twice, so we're just going to list 3, 1. Okay, so sorry. First step wants us to list the possible rational zeros, 1 and 3, with the positive and negative. And then step 2 wants us to use the division, identify the actual zeros, and it doesn't say anything about identifying the multiplicity if they repeat. So we're just going to list 3, 1, and negative 1.